This episode is brought to you by Cisco Educational Premium.
After 40 days, Fior is unable to solve Tartaglia's questions, not even a single one. We should not come as a surprise since Fior wasn't that Italian mathematician and was just hiding behind his teacher's work, Scipione del Ferro. And so Tartaglia becomes the math kingpin of the town and Fior has to abide. What a math duel. We should have one of these fine days. But maybe no. So, coming to think of it, Del Ferro was the only man in the world who could solve depressed cubics. So how did Niccolo Tartaglia manage to solve the hardest problem known? How did he solve the depressed cubic equations? As the saying goes, necessity is the mother of invention. Because solving the depressed cubic equation was necessary for his career, Tartaglia had to become creative. He extends the idea of completing square into completing the cube. For example, he takes the cubic equation x cubed plus 9x is equivalent to 26. Drawing the analogy from before, we can think of x cubic as a cube with sides of length x. The 9x term is a cuboid of volume 9x and the whole thing adds to 26. So as before, we need to do a similar thing and complete the cube. Imagine extending three sides of our cube, a distance y. This will obviously create a larger cube with side z, z being equivalent to x plus y. So we have the original cube deep at the corner and we can break the new bigger cube into 7 shapes. There are 3 cuboids with side x by y and narrower cuboids with side x by y and then finally a cube with volume y cubed. Tartaglia then rearranges the 6 cuboids into 1 cuboid with length 3y with z and height x. This cuboid represents the 9x in our cubic equation. So putting the big cube back together, we find that we are missing the small y cubed. So we can complete the cube by adding y cubed both sides of the equation. X cubed plus 9x plus y cubed is equivalent to 26 plus y cubed. X cubed plus 9x plus y cubed being z cubed 3yz is equivalent to 9. Now we have z cubed, the complete larger cube equivalent to 26 plus y cubed. Now we have 2 equations and 2 unknowns. The first equation is 3yz is equivalent to 9 and the second is z cubed is equivalent to 26 plus y cubed. By solving the first equation for z and substituting the second, we get z is equivalent to 3 on y. 3 on y cubed is equivalent to 26 plus y cubed. Then y cubed plus 26 is equivalent to 27 on y cubed, which is y raised to the 6th plus 26 y cubed is equivalent to 27. Y cubed being its own variable, we get y cubed square plus 26 y cubed is equivalent to 27, which is a quadratic equation and we know how to solve it. Even Fior or Pacioli knew how to solve it. And so from this we get y is equivalent to 1, z is equivalent to 3, x is equivalent to 2. This is the solution to the cubic equation. And so this is how Niccolo Tartaglia became the second smartest mathematician in the world. He summarizes this as a poem. Remember, algebraic notation has not been invented yet. Tartaglia's victory in the duel makes him a celebrity, much like Rihanna or Quavo, but in math. Mathematical community is eager to hear from him. Everyone wants his attention. Girolamo Cagano, our 5th character in the story, is a mathematician based on Milan. He too wants to hear from Niccolo Tartaglia. But as with celebrities, it's not easy to interact with one, and as they are usually adamant to hear anything from their fans, and no one is more adamant as Tartaglia, as he is to the mathematicians around the world, especially Girolamo Cagano. He refuses to reveal even a single question from the competition. However, Cagano is persistent, and he manages to box Tartaglia. On March 25th the same year, 1539, Cagano manages to lure Tartaglia to Milan, and Tartaglia tells Cagano about this method of solving the depressed cubic equation. But there was a catch. Aside from introducing Tartaglia to his wealthy benefactor, Cagano has to swear solemnly that he would not tell anyone the method. He wouldn't publish it in any way, and will only write it in cipher. And as Tartaglia quotes, so that after my death, no one shall be able to understand it. Girolamo Cagano begins playing with Tartaglia's method. Now that he has a way to solve the depressed cubic equation, he wants to find a solution to the full cubic equations, including x squared term, and he finds it. The problem is he can't publish it because of the solemn oath he gave to Tartaglia. And why does he want to publish it just like that? You see, Cagano is a doctor and doesn't need a math job to make ends meet. And for him, the credit is more important than the secret. But then, what gives? In 1542, Girolamo Cagano travels to Bologna, where he visits a mathematician who happens to be the son-in-law to Scipione del Ferro. Remember him? Our second character in our story? Cagano finds the solution in Del Ferro's old notebook that was shared with him during the visit, and it predated Tartaglia by decades. So now he can publish his work without violating the solemn promise he gave to Tartaglia. In 1545, Cagano publishes Ars Magna, the Great Art, an updated compendium of mathematics. In it, he acknowledges contributions of Del Ferro, Fior, and Tartaglia. However, Tartaglia is not happy with this. But maybe to keep this in mind, these guys are still using the geometric analogy to solve these equations. The problem came when Cagano encountered problems that involved the negatives. He asked Tartaglia about this, but he could not solve it too. After all, how could you complete a square by adding a negative area, or complete a cube by adding a negative volume? So what does Cagano do? He ignores the possibility, affirming that the square roots of negatives is as subtle as it is useless. Around 10 years later, our last character in our story, the Italian Raffaele Bombelli, solved these problems that involved the negatives. How did he do it? He stubbornly went through with the calculations using Cagano's method, disregarding the geometrical paradoxes that the square roots of negatives implied. He finds out that the square roots of negatives cannot be called positive or negative, and he lets it be its own type of number. It turns out that Cagano's method works if you stop being too literal and just abandon the geometrical analogy for a moment. This new number was later termed as imaginary number by René Descartes, and later Leonhard Euler introduces the imaginary number I being equivalent to root of -1, whose coordinates lies perpendicular to the real number line. Personally, I think it is the worst name ever. Imaginary, isn't it as real as any other number? This imaginary number, when coupled with a real number, gives us the complex number. Today, complex numbers forms the cornerstone of the mathematics that shape our world. From Euler's formula, e to the ix is equivalent to cos x plus I sin x, to Schrödinger's equation,
Cisco Educational Premium is a section of Cisco Educationals with content that is not hosted here. There are episodes ranging from long to short videos. Remember those good old shots of ours? They are there. So do we get there? Use the link on screen or in the description or in the pinned comment below. Enjoy yourself. And I will see you in the next episode of Cisco Educationals.